Quick notes, inorganic chemistry. First, periodic table. General electronic configuration of s orbital is ns1 to 2, p orbital ns2 np 1 to 6, d orbital n-1 d1 to 10 ns2 ns1 to 2. Is for f block n-2 f1 to 14 s2 p6 d10 n-1 s2 p6 d0 or 1 ns2. Here you remember this table. Property: atomic radius decreases when we move from left to right in a periodic table. See here, you see periodic table. Ionization potential increases in a group, decreases. Electron affinity in a period increases, in a group decreases. Electronegativity increases, in a group decreases. Metallic character when in a period it decreases, in a group increases. Alkaline character of hydroxides in a period decreases, in a group no effect. Acid character in a period decreases, in a group decreases. Reducing property decreases, group increases. Oxidizing property in a period it increases, in a group it decreases. Non-metallic character increases, group decreases. Just remember this thing, students. Ionization potential is inversely proportional to metallic character and it is inversely proportional to reducing character. Ionization potential is directly proportional to oxidizing character. Just remember this one. Electron affinity is inversely proportional to size of the atom and directly proportional to nuclear charge. Electron affinity is greater for chlorine in the periodic table. Ionization electronegativity is greater for fluorine in the periodic table. The second electron affinity is always negative. Electron affinity of chlorine is greater than fluorine. The first element of group has similar properties with the second element of the next group. This is called diagonal relationship. The diagonal relationship disappears after fourth group. Atomic radii. S block elements. Atomic radii Li less than Na less than Kb less than Rb less than cesium. Electronegativity Li greater than Na greater than K greater than Rb greater than Cs. First ionization potential Li greater than Na greater than K greater than Rb greater than Cs. Melting point. The color of the flame. For lithium, the color of the flame is red. Sodium, it is golden color. This is a golden yellow. For potassium, it is violet. Rubidium, it is red. For cesium, you will get a flame test of blue. Calcium is a brick red. Strontium is a blood red color. It is called as a crimson red. And for barium, it gives apple green color. Rb, rubidium and cesium shows photoelectric effect. Stability of hydrates. Lithium hydride greater than sodium hydride, greater than potassium hydride, greater than RBH, greater than cesium hydride. Basic nature of hydroxides. Lithium hydroxide less than sodium hydroxide, potassium hydroxide, rubidium hydroxide and cesium hydroxide. Hydration energy here lithium greater than sodium, greater than potassium, greater than rubidium and cesium. Reducing character, you see it's just inverse to hydration energy. Okay. Next, boron family. Stability of +3 oxidation state. B greater than Al greater than Ga, gallium greater than indium greater than thallium. Stability of +1 oxidation state. Gallium less than indium less than thallium. Basic nature of oxides and hydroxides. B less than Al less than Ga less than Ln less than thallium. Relative strength of Lewis acid. BF3 less than BCl3 less than Br3 less than Bi3. Ionization energy, boron greater than aluminium, aluminium less than gallium, gallium greater than indium, less than thallium. Electronegativity, first decreases from B to aluminium and then increases marginally. Then carbon family, reactivity, carbon less than silicon less than germanium less than tin and lead. Metallic character is also decreases in similar manner. Reactivity and metallic character are similar, whereas acidic character of the oxides, carbon dioxide, that is carbon greater than silicon, greater than germanium, tin and lead, is in increasing order. Weak acid is amphoteric, reducing nature of hydride, CH4. In hydrides, it is inversely proportional to acidic character. Carbon less than silicon, less than germanium, less than tin and less than lead. Just remember this one. Thermal stability, it is in increasing order. That is, you take all the chlorides, it is in increasing order. Oxidation character of metal species in decreasing order. Ease of hydrolysis of tetrahalides, that is SiCl4, GeCl4, this is in decreasing order. Acid strength of trioxides, N2O3 greater than P2O3 greater than As2O3. Acidic strength of pentaxides, nitrogen family, N2O5 greater than P2O5, As2O5 greater than Sb2O5 greater than bismuth oxide, Bi2O5. Acid strength of oxides, it is in decreasing order. N2O less than NO less than N2O3 less than N2O4 less than N2O5. Basic nature, bond angle, thermal stability and dipole moment of hydrides. You see here in hydrides, NH3 greater than PH3 greater than ASH3 greater than Sb greater than Bi. Stability of trihalides, you take in halides, it is also in increasing order. In Lewis base strength, it is NF3 less than NCl3 greater than NBr3 less than NiI3. Ease of hydrolysis of trichlorides, NCl3 greater than PCl3 greater than AS3, it is in increasing order. Lewis acid strength of trihalides, it is also in increasing order. Lewis acid strength among phosphorus trihalides, you take phosphorus compound, PF3 greater than PCl3 greater than PBr3 greater than Pi3. Nitrogen displays greater tendency of p-pi multiple bond with itself as well as the carbon and oxygen. The basic strength of hydrides, I already told this one is in increasing order, the basic strength. Okay. The thermal stability of hydrides decreases as the atomic size increases. The melting and boiling in oxygen family, you see here melting and boiling point of hydrides, H2O greater than H2TE, H2SE, H2S. Volatility of hydrides, H2O less than, it is in reverse order, less than TE, less than SE, less than S. Reducing nature of hydrides, H2S greater than H2SE, H2TE. Covalent character is in decreasing order from oxygen to tellurium. Always remember from oxygen to tellurium. Okay. The acidic character of oxides is in increasing order from sulfur to tellurium. Acidic character is in decreasing order. You take in halogen family, bond energy of halogens, chlorine is greater than bromine, greater than fluorine, greater than iodine. Solubility of halogen in water, F2 greater than Cl2 greater than Br2 greater than I2. Oxidizing power is in increasing order. Enthalpy of hydration of X is in increasing order. You just remember the halogen, fluorine, chlorine, bromine, iodine. Which one is in increasing order, which one is in decreasing order? You have to remember this one. Reactivity of halogen in increasing order. Ionic character is in increasing order. Reducing character is in decreasing order. That is take reversible. Acid strength of halogen, decreasing order. Conjugate base is also in increasing order. Reducing property of hydrogen halides is decreasing order. Oxidizing power of oxides of chlorine. Here see Cl2O greater than ClO2 greater than Cl2O6 greater than Cl2O7. Acidic character of oxyacids of chlorine. HClO is more acidic, less acidic. HClO4 perchloric acid is more acidic than other three, is in decreasing order. Oxidizing power of oxyacids of chlorine. HClO greater than HClO2, HClO3 and HClO4. Now we come to transition elements, D and F block elements. Elements with exceptional configuration. Chromium, copper, molybdenum, palladium, silver and platinum. These are some exceptions. Other has this configuration. The ferromagnetic substances are those in which there are large number of electrons with unpaired spin and whose magnetic moment are aligned in the same direction. Inner transition element. The configuration xenon, inert configuration 4f 1 to 0 to 14, 5d 0 to 1, 6s2. Magnetic property. Suppose if the compound is a paramagnetic, then mu equal to 4s spin. S is the spin, s plus 1 plus L into L plus 1. L is the orbital quantum number and S is the spin quantum number. You see, in coordination compounds, coordination number is the number of nearest atom or groups in the coordination sphere. Ligand is a Lewis-based donor of electron that bonds to central metal atom in a coordination compound. Paramagnetic substance is one that is attached to magnetic field. This results in account of unpaired electron. If the complex has unpaired electron, then it is paramagnetic. Effective atomic number, which is equal to Z minus oxidation number plus 2 into coordination number. You can calculate this formula, the effective atomic number. Greater the charge on the central metal ion, greater is the stability. Greater the ability of the ligand to donate electron pair, basic strength, greater is the stability. Formation of chelate rings increases the stability. Isomerism in coordination complex, it is structural isomerism, ionization, linkage, hydration, coordination, ligand, polymerization isomerism, valence isomerism, coordination position isomerism, stereo isomerism. Geometrical isomerism, you have square planar complex of this type. MA to X2, MAABX2, MABXY. Octahedral type, it is metal MA4XY, MA4X2, MA3X3, MA2X2Y2, MA2A twice X2, MABCDEF. Optical isomerism. General organic chemistry, the order of decreasing electronegativity of hybrid orbitals is sp greater than sp2 greater than sp3. Conformation isomers are those isomers which arise due to rotational around the single bond. A meso compound is optically inactive even though it has symmetric centers due to internal compensation and of rotation of plane polarized light. An equimolar mixture of an enantiomer is called racemic mixture, which is optically inactive. You see, meso compound is also optically inactive and racemic mixture is also optically inactive. Reaction intermediate and reagents. Homolytic fission, which produce free radicals. Homolytic fission means H2N2O2. Heterolytic fission, example HCl. The two atoms are a different atom. You will get ions, that is H plus ion, Cl minus ion. Carbonium ion, carbocation like this. Nucleophiles, it is a electron rich compound is called nucleophile, electron deficient compound is called electrophile. Two types of nucleophiles, one is anion and another is a neutral molecule with a lone pair of electron. For example, anions Cl minus, F minus are nucleophiles. Neutral molecule ammonia, NH3 is a NH3 like this, neutral compound. Electrophiles, electron deficient compound, one is a cation, H plus, Na plus like this cation, and neutral molecule with vacant orbitals is a Lewis acid, BF3AlCl3 like this. Inductive effect is due to sigma electron displacement along the chain and it is a permanent effect. Plus I effect increases basicity. Minus I effect increases the acidity of the compound. You remember this one. Resonance is a phenomenon in which two or more structures can be written for the same compound, but none of them actually exist. That's all about inorganic chemistry. You can download the notes in the description box.